Hello everyone here, this is Eason Lee from Think Academy Singapore. Today, we are going to talk about the change ratio problems. Ratio problems is a very popular questions tested in the most word problem part. The change ratio problems that is a situation that there are two amounts and during a process, one or both of them has changed. And before the change and after the changes, there are a ratio. So by comparing the latter ratio and the former ratio, we can solve the problem. That's change ratio problems. So this type of question have two different situations. The first one that we can find some amount that remains unchanged in the process. So if the unchanged amount, we can easily solve the problems. But in other cases, sometimes we can find that during the process, everything has changed. There is no unchanged amount. So in that case, maybe the algebra is the best way to solve it. Of course, there is a model way here by creating some unchanged amount and compare it. But it will be difficult to think, difficult to calculate, and maybe in the exam, it's best to use the algebra. Okay? So let's look at the two types of questions. First type is come from the 2018 NMOS test, question 15. It was 2 points. So it experienced that if you see a change ratio problem in a 1 or 2 point area, sometimes, maybe always, I think I can say always, it always has an unchanged amount. So we can use the model to solve it. However, if you made a change ratio problem in 3 point questions, it often needs algebra. So you can take the word, okay? So this question is an age problem. About the age problem, something we should know that as year pass, everyone grows, the difference of ages for every people remains unchanged. So age problem, the time you notice it, you should know that what is unchanged? The difference of ages, right? So as we find the unchanged amount, we can use it to solve the problem. So let's see, 7 years ago, David's age was 25% of her sister's age. So actually this question do not mention ratio, it's a percentage, but fraction and percentage are just another different rhythm of ratio, right? So if David's age was 25% of his sister's age, which means David was 25. His sister is 100. So maybe the ratio could be 1 to 4, right? Then 3 years later, David's age will be 50% of his sister's age, 50%, and which is 1 to 2. Notice that I use 2 different colors to write this ratio, for its units are not the same, right? So for 2 different ratios with different units, we should, for the first time, we should unify the unit. But how to unify it? We can use the unchanged amount, which is the difference of their ages. We can write the difference here and represent it by each unit. So 1, 4 difference is 3 units here, and 1, 2, 1 unit here. As I mentioned before, the difference remains the same, and the same amount should be written in a same unit, right? So a 3 here and 1 here, we can unify it into what? Into 3. So let's make it with 3, and from them, everything should be times 3. So the ratio can be 7 years later is 7 years ago is 1 to 4 and difference 3. Now it's 3 to 6, a difference 3 as well, right? So now we unify the unit. Then we can again look into what has changed. 7 years ago and 3 years later. So there are 7 plus 3, 10 years passed. So things changed is that there is 10 years passed. Then 1 unit becomes 3 units, which means 3 units minus 1 unit, that is 2 units, are just equal to 10 years. So now we have the unit and the amount. We can find 1 unit equals to 5 years. Then we can get the David's original age with 5, 20, and then 15, 30, right? The difference remains the 15 years. This is how we solve the change ratio problem if there are some unchanged amount. We use the unchanged amount to unify the unit and solve it easily. But this is not the final answer, as the question asked how many years later will be when David's age is 50% of her sister's age, right? So, when we want to see that David present is 75%, so David would be 3 and her sister would be 4. And the difference now will be worth one black unit. But we already know that the difference of ages remains 15. So here, 1 black unit is just 15 years. And then we can see her sister would be 60 years old and David would be 45 years old. We can see that 3 years later, David is 15 and current David's age would be 15 minus 3 is 12, right? So, when David is 45 years old, it would be 45 minus 12, and it would be 33 years later. So that's the first type of problems. We find the unchanged amount and solve the problems. There are usually 3 typical types of unchanged amount. That is sum, difference, or certain one of the 2 amounts, right? The sum that it happens in a give and take questions. The one gives something to another, then their sum remains unchanged. Okay, the second one, the difference, just in the age problem more oftenly. But in another cases, that when 2 amounts are add or minus the same value, And the third part, maybe sometimes boy and girls, boys increase or boy decrease, but the girl remains unchanged. So these are 3 typical types of unchanged amount. But if a problem has no unchanged amount, such as these problems in 2022, right, it's 3-point questions. I have mentioned that in 3-point questions, usually we should use the algebra. So it says that at first, 55 items were suitcase, and after sold, 60% were suitcases. So before and after, we have 2 percentage, aka 2 ratios, right? And then we sold something. Notice that both the suitcase and cameras were sold, and that the sum changed, the difference changed. So we cannot find an easy unchanged amount. So here, algebra can help. So just let the original items, right? Let the original total items be U. So, this suitcase, this is total, right? So if this will be U, then suitcase would be 45% times U, right? So after changes, we have suitcase, so 12, and total, so what? 12 plus 28 is 40, right? It's 40. So then we have, now the suitcase was 60% of total. Then we can easily form an algebra here, such like the total suitcase equals to 60% of current total. Now let's solve it, which means it's 24 here, right? So then we have 50% U equals 12. So U here will be 12 divided by 50, it's 80. Yeah, it's 80. So the original total number is 80. Then the remaining total number would be 80 minus 40, right? It's a 40. So use the algebra, we can easily solve it. So this question, we have a model way to solve it just by use the percentage. But this is a more advanced way to solve it, and I don't expect you to all know how to do it. And in a real NMOS test, maybe algebra is your best friend. So that's all for today, but remember, do not forget our seminar this weekend. We will tell you how to answer questions, how to choose the best method to do it. Okay, thank you. I'll see you tomorrow and see you at the seminar.